All right, so DP is all about figuring out which subproblems are relevant to the solution to the overall problem. So for this routing problem, where we're trying to find a shortest path from green to red, the subproblem that we care about is the shortest path from each intermediate node to red. Okay, so to identify that, we're going to start at the end and work our way backwards. Okay, so sometimes just thinking about the problem in reverse can help us arrive at some kind of good approach to a solution. So we'll work from the end backwards, from end backward. And then what we'll do is at each node, we will record the optimal cost that would take us from that node to the end, and we'll record the decision that needs to be made at that node. Okay, so we record two things at each node. At each node, record first the optimal cost, and we'll call this the optimal cost to go. Cost to go, right? And so the cost to go is the length of the shortest path from that node all the way to the end. Okay, and the optimal decision to make from that node. And the optimal decision at that node. Okay, and so let's work through this. Let's work through this and see how this works. The basic idea is that then at each node, we don't have to try to think all the way to the end. So when suppose we've solved all the shortest paths from these nodes, the idea is then once we're at this node trying to make a choice, we know how costly the tails of all the further paths will be. Right? We will have already recorded what to do at each of those other nodes, so we can just take the thing that we know to do from those nodes and incorporate that into our decision at the previous stage. Okay, so let's actually work through this. Let's do this for the entire problem here and figure out what to do. So I'm going to zoom in a little bit, try not to obscure myself too much. And what I'll do is at each one of these nodes, I'm going to write down in red the optimal forward cost, right? The optimal cost to go, and I'll write down the optimal decision to make. Okay, so let's begin here, and I'll mark a node in red once we're there. Okay, so at this node, I have three choices to make. Right, I can go up, I can go middle, or I can go down. So let me write down the costs of each of those choices. Right, so up has a cost of 6 plus 4. Right, so I have to incorporate the terminal cost here. So up has a cost of 6 plus 4 is 10. Right, middle has a cost of 3 plus 3, which is 6. And down has a cost of 0 plus 5, which is 5. Okay, so what is the optimal cost to go? Well, the optimal cost is 5. So on this node, I'm going to write 5, and that means that if I'm here, the shortest path has a cost of 5, and then I'll write an arrow that says what to do. So here's my arrow, right? So if I am at node 5, I go down, and the resulting cost will be 5, right? So now I've just made a note of that to myself for future reference. So now let me move on to this node. So at this node, I have 3 choices to make, and I'll write them down here, and I won't be quite as exhaustive for all these, but I want to do a couple steps just to make sure that it's clear what's going on. So at this node, if I go up, that'll be a cost of 7 plus 4, right? What's the 7? Well, the 7 is this one. And what's the 4? The 4 is this one. Okay, so if I go up, it's a cost of 7 plus 4, which is what? Which is 11. If I go mid, that's a cost of 7 plus 3, which is 10. And if I go down, that's a cost of 7 plus 5, which is 12. 7 plus 5, which is 12. Okay, so what's the optimal cost to go? Well, it's 10. The optimal cost is 10, and the optimal decision to make is mid. Right? So if I am at this node, right, if somehow I ever find myself at this node, now I'm going to make a note that says, here's what to expect later on down the road. Okay? What you'll expect to see is a cost of 10. Right? The distance from here to the end is 10. And to achieve that distance, go mid. Okay? So this is the approach. So let me do the bottom one a little bit faster, and then let's interpret what we have accomplished so far. So the bottom one now, I have a cost of 1 plus 4, which is 5. Right? If I go up, I'll have a cost of 5. If I go mid, I'll have a cost of 5. And if I go down, I'll have a cost of 8. Okay? So it doesn't really matter. So I'll just say go up. I'll break ties by going up instead of middle. And so the total cost to go from here is 5. And I achieve that cost by going up. Okay. So now what do I have? What have I accomplished so far? Well, take a look at each of these nodes that are now colored in red in this stage 2. At each of these nodes, I have a plan. Okay, I have a plan, and I have something that tells me how much that plan will cost. So at the top node here, my plan is go down, and then follow the map from there, right? But here, the decision you have to make is go down. If you go down, the total cost you will ultimately experience is 5, right? So where does that 5 come from? Well, it comes from the cost of immediately going down plus the cost of whatever comes after going down. Okay, the cost of immediately going down is 0, right? And the cost of whatever comes after is 5, as you can see right here. Okay, so now, can I decide which one of these nodes I want to be at this stage? Well, not necessarily, right? So you might look at this and you say, hey, I've got a node with a cost to go of 5, got a node with a cost to go of 5, right? Those look like they're the same. And then here's a node with a cost to go of 10. So whatever my path is, it should probably avoid the 10. That actually is the wrong way to think about this, right? It's what we have here is only a plan going forward if we ever come to these nodes. What we don't yet have is a plan on how to get to these nodes. Okay, so to come up with a plan on how to get to these nodes, we have to go a step back, right? And that will give us more information about what to do once we come to these nodes. Okay, so let's go a step back. So I'm going to erase. Let me have that circled. So this will stay here in the top right, but I'm going to erase this so that I can record some stuff in the previous one here. So I'm going to switch to blue. So here we are. I'm going to switch to blue for this one. So when I'm not erasing, blue, there we go. Okay, and let's make that small. So what we have in this stage is, suppose we're at this node, we have to figure out what to do. So from this node, we have to decide what is our next plan and how much will that plan cost us. Okay, so suppose we're at the blue node here and we go up. What that will do is it'll give us a cost of 5, right? It'll cost us 5 to make that decision immediately, and then it'll cost us an additional 5. It'll cost us an additional 5 so our immediate cost will be 5. And then there will be a further cost resulting from the path that will follow from this next node, which is 5. So the total cost of going up is 10. So let me pause just a moment and make sure this is clear. What I'm saying is that if I am here at this node, this blue node, and I'm trying to understand what is the cost of going up, because I've already recorded the cost from this node, all I have to do is add the cost that will result from a path from this node to the cost of getting to this node, and now I know the cost of getting to the end. Right? So to understand, because I've answered the questions here, to understand how long it's going to take me to get from the blue node all the way to the end, all I have to do is look one stage ahead and then check in this table of results that I've accumulated in the next stage. Okay, so what this says is that going up is going to cost me a total of 10 to go on. Going middle is going to cost me now 0 plus 10, right? Where are these numbers coming from? Well, 0 is here. So 0 is the cost of going middle, right? It's the cost of getting to the next stage. And then what's the 10? Well, the 10 is the cost of moving on once I'm in the next stage. So the total cost ends up being 10, right? If I go middle. So what if I go down? Well, going down gives me an immediate cost of 1 and then a future cost of 5. Right? So I get an immediate cost of 1, which is the cost of getting to the next stage, plus a cost of 5, which is the cost of getting me from the next stage to the end. And I've already recorded that in my table, so I don't have to look it up again. So that means going down gives me a total cost of 6, right? Which is considerably better than the cost of 10 that I would get if I went up or middle. Okay, so this gives me now a plan. So now from this node, I know that my cost to go is 6, so I'll record that. And to get that cost, I need to go down. Okay? And so now this gives us a completely different answer than the greedy algorithm would have given us. The greedy algorithm would have said, hey, take that 0 and go on. Well, the 0, we know now, because we've solved the second to last stage, we know now that 0 would take us to a 10, which would cost us a lot in the future. Right? So essentially what DP is doing is it's saying, hey, if I know what's coming ahead, that can help me make a decision now. Right? I can evaluate my immediate cost in light of my known future costs, essentially by exploiting problems I've already solved. All right, let's go on and finish solving this problem. So if I want to look at this node, if I go up, that's going to cost me 2 plus 5, so that'll be 7. If I go middle, that'll cost me 1 plus 10, which is 11. And if I go down, that'll cost me 2 plus 5, which is 7. So let's break ties with up. That's fine with me. It doesn't matter. And we'll call that the optimal choice. And the optimal cost to go is 7. All right, and now from the bottom node, I've written an infinity in here. And so infinity is a useful device for thinking about either edges that don't exist or edges that are costly in a sense that we don't want to follow them. And so if I go up, that's going to be a cost of infinity. So that's going to be, anything is going to beat that. If I go mid, that's going to be a cost of 11, cost of the 1 plus the 10. Okay, so that's 11. And if I go down, that'll be a cost of 0 plus 5. Right, so the cost to go from this node is 5. Right, and the optimal decision to make is down. Right, so now all we have to do is solve the first node, right? Solve the very first stage decision. And we have all the information we need to do that. So I'm going to fill this thing in with green to say now we're here. And so from the very first stage, if we go up, we'll spend a cost of 1 to get to the next stage, and then a cost of 6 to go on from there. So that's 1 plus 6, which is 7. If we go mid, then we'll spend a cost of 1 plus a cost of a cost of 2 to get to the next stage, plus a cost of 7 to go on from there, which is a total cost of 9. So mid is 2 plus 7, which is 9. And if I go down, that'll be a total cost of 8. So if I go down, that's a cost of 3 plus 5, which gives me 8. And so what's the optimal thing to do from here? Well, it's go up to get a cost of 7. All right, so there's our up, and the total cost will be 7. And now what does that 7 tell us? Well, the 7 tells us that if we follow the arrows, right, if we start at the green and follow the green arrow, and then follow all the arrows further on, that our total cost, the total cost of our path, will be 7. Okay? And so the number I write in here is the minimum cost, or is the cost of the minimum cost path. Right? This is the cost of the minimum cost path. How do I find the path? I just follow the arrows. Right? So what is my minimum cost path? Well, the minimum cost path is just the thing that follows the arrows. So here's my min cost path. Well, it's up. That's what my first arrow says. Then it's down, right? That's what my second arrow says. And then I'm here and it's up again. So up, down, up. And that's a minimum cost path. The claim is that's a minimum cost path. And we can just verify that it is, right? What are the actual edge costs that would be incurred if we followed this path? Well, going from green to up would be a cost of 1. Going from blue to down would be a cost of 1. Going from red to up would be a cost of 1. And then the terminal cost would be 4, right? And so if I add all these up, I get 7. Sure enough, just like I claimed right here. Okay, so this is DP, right? DP involves identifying the subproblem that is relevant to the solution of your overall problem. And then once you have identified that subproblem, go solve all the subproblems you need to construct a solution to your overall problem.